Welcome back. This is the last lecture in this series of lectures on general nuclear reaction. Um, Photons themselves can be used for nuclear reaction. This is particularly interesting. For example, if you expose low energy photon to deuterium, because deuterium has a binding energy of 2.2 MeV. If the photon has an energy more than 2.2 MeV, deuterium can disintegrate into a neutron and a proton. So here we start with deuterium, um, expose it to a photon with energy greater than 2.2 to form uh, hydrogen with just one proton, no neutron, and the neutron gets ejected. So likewise, if the gamma photon has an energy greater than 2.62, it is possible to remove one of the neutron from beryllium nucleus of atomic mass 9. Okay, so this provides an estimate of separation energies. Um, Sometimes, upon exposing to photon, you may not have particle emission, but you may just have uh, a gamma photon emission of different energy. For example, here, all you're doing is that you're exposing it to gamma, but this gamma has a different energy. Therefore, these states can be excited states of this nucleus. So this is a similar system. We'll move on to exposure of a nucleus to high photon energies. Um, if you expose it to higher photon, as you know that the separation energy increases with atomic number and atomic mass, you need photons of greater energy to eject a neutron. So is similar to what was mentioned in the previous slide, but here the energies are greater. Therefore, it is possible to eject a neutron even from a high Z nucleus. Uh, And this is even more interesting when you have a photon of more than 25 MeV. When exposed to C12, it breaks down into 3 alpha particles. Uh, so this is also a well-studied reaction. So this has been important historically because this was one of the reaction which uh, provided experimental evidence for Einstein's mass-energy relationship. Let's move on to inducing nuclear reactions via heavy ions. By heavy ions, we mean ions that are larger or heavier than alpha particle. For example, this is one of the heavy ion reactions. You need a fairly sophisticated accelerator. So this projectile reacting with this target gives rise something like a disproportionation reaction. This is what is called a transfer reaction. Here, the transfer reaction products might have particular discrete angular momentum and are emitted at particular angles. Okay, so this kind of uh, structures in the products have give a lot of insight into nuclear structure. Okay, it gives the idea of resonances, as I mentioned in some previous lecture. Resonances. What we mean by resonances is in certain particular energies, the reaction cross section increases and the energy transfer becomes much more efficient. So these kinds of reactions are very important to get an idea of nuclear structure. These are fairly sophisticated topics beyond the scope of this course, but we're just giving you some pointers to interesting material you can read further uh, in references provided in this book and other sources. So these transfer reactions might have many different exit channels. That is more than one particular product is possible. Here, this is the projectile, this is the target atom, and a variety of products can be formed depending upon the ejectile. There are a lot of heavy ion reactions. These are all fairly advanced nuclear reactions. So the even a theoretical model for these things are sophisticated and beyond the scope of this course. But I'm just giving you some examples that are mentioned in this book of heavy ion induced reactions. All these things involve heavy ions as a projectile. There's another. So most of the models that we discussed more elaborately had to do with what is called a compound nuclear reaction model. There is another model which is also well quantified, and there are fairly good theoretical description available, but we will not look into this uh, elaborately in this course. Uh, these are so-called direct nuclear reaction models. In this, a compound nucleus is not formed. Okay, so the essential aspect of a compound nucleus is that the projectile's energy gets equilibrated into the entire nucleus. Um, in a direct nuclear reaction, the projectile collision seems to excite only a part of the nucleus. Okay, so because of inhomogeneity in energy distribution, a part of the excited part of the nucleus gets ejected out. With this, we complete this series of brief lectures on nuclear reaction. We will move on to another topic, which is also very important, which is to do with nuclear fission and fusion. We will start the discussion on this topic in the next lecture. Thank you.